Today is Thursday, August 27th. We are working on the bell ring, the math workshop. We are on number 3. Okay. I'll look at this, -3 minus 6, as two negative numbers because a minus sign and a negative sign are the same thing. So I'm not going to keep change. Now, if that's your method and it works for you, you can use it, okay? I'm just trying to show you a different way in case you don't like that method or you don't understand it. It's less work, in my opinion. So as soon as I see that, I say, ooh, the signs are the same as. They're both minus, because minus and negative is the same. So signs are the same as, so I get 9, and I keep the sign, -9. But on this one, on number 4, I have to change because I have two negatives next to each other. And that's like saying -1 times -1, and that's positive. So that's why two negatives equals a positive. Okay, so then I look at what I have, -11 plus 11, so the signs are, I get, number 5, are the signs the same or different? Different, so 6 minus 13, I have to subtract, and I get 7, and I keep the sign of the larger digit, which is 13, so I get -7. Okay, we have a quiz tomorrow. Virtual kids, you have a quiz tomorrow, and on-campus kids, you have a quiz tomorrow. The quiz is going to cover rational and irrational numbers, okay, like the little graded assignment you did yesterday. You need to study those notes that we took where we wrote the numbers in the boxes, okay? You're going to have to know what whole numbers are, what natural numbers are, integers, rational numbers, irrational numbers. I think that's all of them. And then what we did yesterday where we were changing the repeating decimals to fractions, that will be on the quiz as well. Okay, so let's review that really quickly. You had a sheet yesterday at the end of class that looked like this. So take that out. Take this out. Yeah. And let's go over a couple of these that I haven't worked yet, just to remember how to do this, okay? So I'm going to go to the point 6-3 with the bar over the 6 and the 3. So it's the third one on the left. All right. The bar is over both digits. So that means both digits are repeating. Okay, so that is my numerator, 63. Now, how do I figure my denominator?
You count, you put a 9 as the denominator every number that has a bar over it.
Good. A 9 for every number that has a bar over it. So how many 9s does this fraction get? 2 9s. You held up 2 fingers, Nathan? That's answering, bud. Alright, so it gets 2 9s. And then the last thing I do is check to see if it can be simplified. And I told you guys yesterday, these giant ones, I'm not worried about you simplifying, okay? Because without a calculator, you would be simplifying for hours trying to get that to its reduced form. We're not going to worry about those giant ones. But ones like this, I can look and I know that both of those numbers can be divided by 9 because I know my 9s. So I would say 63 divided by 9 is 7 and 99 divided by 9 is 11. So I get 7 over 11. Now let's look at the next one. 0.875. The bar is only over the 7 and the 5. So when the bar is not over every digit, what do I do first? Good job. I subtract. What am I going to subtract? Minus what? 8. Good. And I get 867. That number is my numerator. Now how do I figure my denominator? 2 9s. Why does it get 2 9s? Great job, guys. There's a bar over 2 of the digits. So it gets 2 9s. And then what does the 8 provide for us? What do we get there? 1 0. 867 over 990, which I'm sure can be simplified, but you don't have to worry about that. I'm just not going to make you spend that much time trying to simplify those big fractions. Alright, let's skip around. Let's go to this one right here. 0.416 with the bar over the 6. What do I do first? Good. By 41, because the bar is only over the 6. So I'm subtracting the numbers that the bar is not over. So 6 minus 1 gives me 5, and this is 7, and this is 3. So I get 375. 375 over. How many 9s? 1 or 2? 1. How many zeros? 2. Excellent. Now, this one ends in 5 and 0. I know it can be simplified by 5, but it probably can be simplified by a larger number too. I'm not going to penalize you if you leave it like this, but if you divide it by 5, that's great too.
Yeah, I actually worked out 9. I ended up with 5
12.
That's the only one where I messed up on.
Yeah, because
That's all the lines
over the 1, 2, yeah. All right, are there any questions about this? Y'all seem to get it pretty well. Good? Okay, so that's on the quiz tomorrow as well. All right? Is there anything else we've been covering in class this week that I might have missed?
Can you go over perfect squares, please? Because that's the one thing, like on that quiz, that's all I missed. Like that little test thing I missed.
Okay, let's go over perfect squares. In fact, that goes along with today's learning target, so you can go ahead and open to classwork section and we'll take some notes on that, okay? So today's learning target, we just did, I can write repeating decimals as fractions. But the new one is I can solve perfect squares and cubes. So just write that one. You don't have to write this one because you've already written that one. I can solve perfect squares and cubes.
Can we write the notes under the learning target?
Yes. That's my intention for you to do, Kelly.
People doing virtual have to write down the learning targets and stuff.
Say it again.
People doing virtual have to write down.
No, they're not writing learning targets. Sorry, his teacher texted me. All right. They are getting the learning target through these videos, though. Alright, I can solve perfect squares and cubes. We're going to talk about perfect squares first. Let me pause the video for a second. I think I did a little branch, but I gotta look. Oh wait, no. Just one? Just one little break? You're welcome. Okay, perfect squares are numbers that multiply times themselves to give you another number. So, we're going to write the perfect squares through 20. And you are going to have to memorize these, but not for tomorrow's quiz. Okay. What is 1 squared? That means 1 times 1. 1. 2 squared. 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. 12 squared. 13 squared. How far can you go? Nope. Anybody? Figure it out. 13 squared.
I forgot my multiplication back in like 6th grade.
We studied these in the park stuff, you know, the random little park stuff. I forgot it.
You got it? Nope, close. You got it, Blanca?
Isn't it 180?
169. You know it is in 9 because 3 times 3 is 9. 14 squared. It just flips the 6 and the 9. 196. 15 squared. 225. That was close. What about 16 squared? Are y'all going to be lazy or are you going to multiply it out?
I'm only good at math when I have a calculator.
Close. 256. 17 squares. 289.
I remember that one.
What about 18 squared? $324. 19 squared. 361. And y'all should know 20 squared. 400. Alright, those are perfect squares. So the opposite of perfect squares, of squaring a number, is taking the square root of a number. And another word for the square root symbol is radical symbol. Okay, so the square root of 1 is 1. The square root of 4? 2. The square root of 9? Catching on? Square root of 16? I've got them in order, so you can just go down and... Now, a lot of you missed this one on the little, not the quiz, but the worksheet yesterday. The square root of 121 you said was irrational, and it's because you didn't recognize it as a perfect square. But it is a perfect square because 11 times 11 is 121. So that makes it rational. Rational, not only rational, it's a natural number and a whole number. So these will be all jumbled up, and it'll be like a 3-minute test.
Oh, is that like the 9 weeks memorization test?
Yeah. That's the 9 weeks memorization test, Kate. There goes my air again. Alright.
I'm not done.
Okay.
Still got a long way to go. I got confused.
Okay.
That air, I still get it on.
It is. I'm about to cut it off for a little while. Anderson, can I move the paper? Like, where are you?
I'm on the last row.
This one?
On the square root.
Can you see, which one are you on?
I just started.
Okay,
Because
okay.
On the squared ones, I wrote 11 through 20 wrong. And I had to go back
And change it, okay. Well, next we're going to do cubes. So, you guys, and we're not doing through 20, we're doing through 10. So you can write 1 to the third equals 2 to the third equals all the way to 10 to the third. La, la, la. Okay, so this is the part of the learning target that goes with I can solve perfect cubes. So 1 to the third power means 1 times 1 times 1, which is 1. 2 cubed, or 2 to the third power, would be what? 8. Oh, I don't need to write over there. I'm going to be writing my cube roots. 3 to the third power, or 3 cubed, would be 27. We want to say 9 because we think 3 times 3, but what it really is 3 times 3 times 3. You're multiplying the numbers together 3 times.
Yeah, 39 times 3.
Right, it would be 9 times 3. So 4 to the third would be 4 times 4, which is 16, times 4, which is 64. 5 times 5, 25 times 5, 125. 6 times 6 is 36 times 6. That's it. 7 times 7 times 7. 383? I was thinking 343. Hold on. Yeah, 343. Eight times 8 times 8. You're doing 64 times 8. And 9 cubed? You're doing 9 times 9, which is 81. And then you do 81 times 9, 72. 8 times 9 is 72. Yes. What'd you say, Anderson?
I said I would answer it, but I don't know what 8 times 9 is.
Boy, you're going to have to memorize these, okay? Because it's going to be a time test. It's going to be a major standards-based assessment. And 10 to the third, that one's easy. 1,000. So this is a cube root symbol. It's a square root or a radical with the 3 in the outside little hook. So that means the cube root of. Abby and Kate. The worst thing about a mask, my facial recognition doesn't work. First world probs.
Oh, Mr. Smith was talking about like his now he can set his state like on the like I need to set too, so he was like almost that one where it's normal and another one with a mask on.
Really?
It's the only reason if it works or not, but
Oh, I need to try that.
It's always been like that. There's still just one. You just take 2 pictures of yourself in that one. It's always been like that.
Oh. Alright, cube root of 1 is 1. Cube root of 8, 2. Cube root of 27, 3. Cube root of 64 is 4. Cube root of 125 is 5. Cube root of 216, 6. Cube root of 343, 7. Cube root of 512, 8. Cube root of 729, 9. Cube root of 1010. Does that help, Kate?
Yes. So basically, when it goes to like the square root, if it won't fit, like if you can't multiply it by something to get zero, or like to even it out, it's normal.
It's irrational. That's right. If it's a non-perfect square, and of course there's an infinite number of perfect squares, but you only have to memorize through 20. But if it's a number in between these perfect squares, like a number between 16 and 25, it's going to be a non-perfect square and it'll be irrational. Y'all got it? Okay. In your desk, there's the little book, and it says volume 2, and it's probably at the top because, it says volume 1, course 3, volume 1. It may be at the top if there was somebody sitting in your desk last period. And we're going to go to page 71. And we are not going to write in the book. Okay? We're not going to write in the book. Okay. A square root of a number. Remember our learning target. I can solve perfect squares and cubes. Okay? A square root of a number is one of its two equal factors. Numbers such as 1, 4, 9, 16, and 25 are called perfect squares because they are squares of integers. Okay? We just talked about that when we wrote the perfect squares. So when you take the square root of the number, you are providing the perfect square that multiplies together to give it that number. So the relationship, it says, what is the relationship between squaring a number and finding the square root? They're the opposite. Okay, so they're opposite sides of the same coin, so to speak. When I square a number, it provides, like 4 squared gives me 16, and then the square root of 16 is 4. Okay? The square base of the Great Pyramid of Giza covers almost 562,500 square feet. How could you determine the length of each side of the base? What's true about squares? All the sides are the same, right? They're congruent. So, if I knew that the area was 562,500 square feet, and I know it's a square, then how would I find the length of one side? What could I do? Real simple. Goes right with what we're talking about. What's our learning target? Cubes and squares, perfect squares. So is this, what am I dealing with here? Am I dealing with 3D or 2D? If I'm not talking about the whole pyramid. I'm just talking about the square base, okay? So that's 2D, right? So that would be squared, right? So 562,500 is the whole area of the base. Then they squared the length of one side. So I have to undo that to find the length of one side. So what did we just say was the opposite of squaring a number? Finding the what? the square root. So all you would have to do is take the square root of that number, and it would give you the length of the side. You would use a calculator, and there's a special key. You have to hit second x squared, and then put the number in. Yeah. You probably wouldn't do that one by hand. Okay, turn the page. A square root of a number is one of its two equal factors. If x squared is equal to y, meaning if a number to the second power is equal to another number, then x is the square root of y. 5 to the second power is equal to 25, so 5 is the square root of 25. Every positive number has both a positive and a negative square root. In most real-world situations, only the positive is considered. A radical sign, or the square root sign, is used to indicate the principal square root. If n to the second power equals a, then n is equal to the positive or negative square root of a. Why does it work that it could be positive or negative? If I take the square root of a number, if Nathan told me the square root of 16 is negative 4, and Anderson told me the square root of 16 is 4, and I said you're both right, how is that possible? Because they're both what?
It can be negative.
Why?
Even rational numbers are negative.
Yes, rational numbers can be negative, but why does it work?
The answer's going to be the same even if it's negative.
Why is the answer going to be the same even if it's negative, Anderson?
Because it's still the same numbers, it just has a minus in front of it.
And a negative times a negative gives you a what?
A positive.
On fire. And then it never does my passcode right. Okay, so the square root of 64 is 8, because 8 times 8 is 64. Also, negative 8 times negative 8 is 64. But look at number 2. Why does that one look harder?
It just looks like it's bigger.
It's bigger, and it has a what? It has the plus or minus, and then what else does it have? A decimal. Okay, look at that number without the decimal. What is it? 121. And we just wrote the perfect squares. What's the square root of 121? 11. So all we got to do is say 11 and then go put the decimal in there. 1.1. Okay, so it looks harder, but it's not. And it could be that plus or minus means positive or negative. You say plus or minus 1.1. Why does this one look harder? It's a fraction. What do you notice about the denominator and the numerator, though? And what about them? What else?
36 is odd.
Odd?
Even.
25 is odd.
Well, I thought it was like... nothing...
It's a negative square root.
You can't...
She got it. All you do is take the square root of the numerator and the square root of the denominator. Waka got it.
You wanted us to answer the question.
Well, you didn't have to give me the answer,
I didn't
but
know how to answer it.
yeah, I was asking, what do you notice about 25 and 36? They're perfect squares. So all you have to do is take the square root of 25, which is 5, and the square root of 36, which is 6. And then because that negative is outside, the answer is negative. Okay, so pay attention. If you've got negatives on the outside, you've got to include the negative in your answer. Okay? Now, if you've got a negative on the inside, that is called an imaginary number, and you don't deal with imaginary numbers until Algebra 2. So for you guys, if there's a negative in the square root, it's going to be no solution. Alright, because there's no real square root, because no number times itself equals negative 16. Because if I say negative 4 and I multiply by negative 4, I get positive 16, like Anderson said a minute ago. If I multiply positive 4 times positive 4, I get positive 16. I can't say negative 4 times positive 4. That's not a square. It has to be the same number.
Yeah, so it would have to equal negative 16.
Right, and there's no way you can get that. So that is impossible. It's not impossible, but it is for us. It's imaginary. So just get that in your mind. When you see a negative inside the square root, no answer, okay? No solution. Okay, so what would be the square root of 9 over 16? 3/4, good deal. Plus or minus the square root of 0.81? Okay, alright. And don't forget, if it's got that plus minus on the outside, you include it in your answer. Okay? Negative square root of 49. Negative 7. Square root of negative 100. Impossible. If there's negative inside the square root, it's impossible. Because negative 10 times negative 10 is 100. Positive 100, not negative 100. So anytime you see that negative inside the square root, no answer. Okay? Alright, what if it's written as an equation? So this says t to the second power equals 169. When we solve equations, we work backwards. We do the opposite. Remember, if it's adding, you subtract. Multiplying, you divide. Okay? Well, if you're squaring, then you take the square root to solve. So notice how it says t to the second power equals 169, and then it says t is equal to plus or minus the square root of 169, because what they're going to do is take the square root of 169, and that's going to give you t. Now t can be two different numbers, because remember, the square root of a number can be positive or negative. Alright, so we get 13 and negative 13 because the square root of 169 is 13. And see, they included that plus or minus on the outside there. Okay? So 289 equals a squared. I'm going to take the square root of 289. And what's the square root of 289? 17. M to the second equals 0.09. What's the square root of 0.09? Y'all squared it. Take square root. 0.03. Or would it be 0.3? Which one? 0.03? Let's check it out. .03 times 0.03. 1, 2, 3, 4. That gives me 0.0009. I need 0.09. So what's the other one we want to try? 0.3. 0.3 times 0.3. 1, 2. 1, 2. 0.09. Why does that work like that? Because when we multiply decimals, remember you have to count the number of spaces behind the decimal to get your new decimal. Okay? So that's why it's 0.3 times 0.3 instead of 0.3 times 0.3, because that gives it too many zeros. Okay, so that would be 0.3. Okay, y squared equals 4 over 25. What would be the square root of 4 over 25? 2 over 5. Good, 2 over 5. Okay, so that's square roots. Any questions about square roots? Do we feel better about square roots? Okay. Now let's talk about cube roots. A cube root of a number is one of its three equal factors. If a number to the third power is equal to another number, then that number is the cube root of the answer y. Numbers such as 8, 27, and 64 are perfect cubes because they are the cubes of integers. 8 is equal to 2 times 2 times 2, or 2 to the third. 27 is equal to 3 times 3 times 3, or 3 to the third. And 64 is equal to 4 times 4 times 4, or 4 to the third. The symbol cube root of is used to indicate a cube root of a number. If n to the third equals a, then n is the cube root of a. You can use this relationship to solve equations that involve cubes. So the cube root of 125, y'all wrote it down. The cube root of 125 is 5 because 5 times 5 times 5 is 125. Now, Abby, these, you can have a negative inside the cube root symbol. You know why? because a negative times a negative times a negative is a negative. An odd number of negative signs multiplied together gives you a negative.
Make it a positive and then...
Right, it would make it a positive and then it would become a negative. So I can say negative 3 times negative 3 is 9 times negative 3 is negative 27. So I can take the cube root of a negative number. Cannot take the square root of a negative number, but I can take the cube root of a negative number. Alright? Now, we wrote all three of these down. So what's the cube root of 729? You can go back and look. 9. What's the cube root of negative 64? Negative 4. Cool beans. What's the cube root of 1,000? Great job. Okay. Dylan has a planter in the shape of a cube that holds 8 cubic feet of potting soil. Solve the equation 8 is equal to s to the third to find the side length of the container. So when it says 8 equals s to the third, the opposite of the third is cube root. In other words, the opposite of cubing is taking the cube root. So the cube root of 8 is what we have to find the side length there. And that would be 2 times 2 times 2. So the cube root of 8 is 2. So when we're solving square root equations, we take the square root. Squared equations take the square root. Cubed equations take the cube root. Okay. We're going to end there. Do you have any questions? Okay. So after the quiz tomorrow, we'll actually do some work. I have these copied for you. And so you can write on them, and we'll do some work after the quiz tomorrow. So please put the books in the desk. Don't leave them out.